Everybody, and welcome back. So here we do air and water. Well, opposite order. We do water and then air. Okay, so just like last time, we had a sort of thought experiment in our heads, okay? Before it was trash, now we do it with water, right? So you go and you turn on the sink, you wash your hands, you turn the sink off, the water goes down the drain, and then it goes to... yeah. So that's about where most people would stop as far as their knowledge of this one, right? The question of where it goes from there is not something that we ever have to think about. Nobody is making you, and you may not feel like you have an immediate reason to think about it, but at the same time, it's kind of sad if you don't know, but 99% of people don't know because they don't have to. Where does it go? So, water that's going through the sink would be considered gray water, right? So this is water that has been used, but is not contaminated by things like human sewage, right, or other toxic chemicals, which would be considered black water, right? And you'll notice, I know the text is a bit small, right, but there's places in every house, essentially, where you have gray water that is produced and then moved out of the house, or black water. Now, some places consider kitchen sinks to be gray water, some consider them to be black water, kind of depending on what part of the country you're in, right? But in general, right, stuff that's coming out of toilets or other sources where it could be contaminated, black, everything else gray, like washing machine would be gray water. Awesome. So where does the water go from there? Pretty much regardless of where you are in the entire world, right, there's going to be these sort of steps, right? There could be complications along the way, there might be extras, but it's going to follow this general pattern, right? You take the wastewater away from homes and businesses, and it is not all just mixed together into one, right? It is separated into gray water and black water along the way, which is why we kind of talk about that, right? It is delivered to these wastewater treatment facilities. Again, some treat gray water, some treat black water, some treat both, but these are different processes to treat them based on what's in there. And then it's typically dumped, right, back into a lake, back into some sort of surface water source like a river. Sometimes it is dumped into the ground and it becomes part of the recharge process, so it's dumped into the ground. As it filters through the ground, it actually helps to improve the quality of the water even more, and then it can be removed from the groundwater system using a well somewhere else and be really, really high quality. This is good. This is a good practice. Sometimes it is reused directly, and this really depends, right? But this would be if you've ever heard of reclaimed water or effluent wastewater, all right, can be reused. Typically, this does not go back into drinking water systems. In other words, it's not something at our houses where we're going to be drinking recycled, like, black water. But it happens in some places. I know Wichita Falls in Texas has it. I know that reclaimed, black water is used for a lot of outdoor uses and residential uses for those of us here in the valley, right? Things like golf courses and watering lawns. Awesome. So we can zoom in on this process a little bit, right? Wastewater treatment facilities and what that actually looks like. Now, before we get to the process on this one, we have to remember, right? Before we had these kind of sophisticated treatment systems, right, it's a lot of waterborne disease and infectious agents, all right? Diseases horrible that very few of us actually get these days, right? Dysentery, cholera can be deadly, can exacerbate dehydration, usually come from fecal contamination of water, not so common now. On the other hand, right, we have these New World problems which come with side effects. The New World problems are far superior to the Old World problems, but they're still there. Side effects like what? Well, if you put chlorine into the water and other chemicals in there which are disinfecting agents, you can get complications related to how that water reacts with stuff. As far as what is going on here with the black balls, I'm going to link a YouTube video and leave it as a mystery. Highly recommend, but it's related to the stuff that we're talking about here. Cool. Water treatment facilities. Again, this is going to vary a lot depending on where you are, but they're pretty much always going to have these same steps. For now, remember, right, we're treating black water and gray water differently, but they're going to go through these same steps no matter where you are. We're going to pretend like it's all the same. So the first thing, they call it coagulation and flocculation. What does this mean? Essentially, you want the particles of dirt and toxic stuff and waste and whatever to get larger, right? If it's too small, then you can't filter it out at a larger stage. So the first thing, right? You want to make these things stick together. You want them to get bigger. In the sedimentation stage, you want all of this stuff to sink down to the bottom, where it can be caught and filtered in traps, right? As this thing kind of spins around and filters the water using very complicated screens, essentially, right? It'd be disinfected. Usually this is with chlorine, could be with another additive to kill it. And then it goes off where? Usually to be recharged into the ground here in Arizona, or to a surface water source, lakes, rivers. Sometimes it's recycled and put back into people's outdoor water supplies, and we've done it. We've done water. Okay. Air pollution. Big topic for those of us here in Arizona. You might be familiar with the process of vehicle emissions testing, and that more so sums up the approach on air, right? So with air pollution in general, it's not feasible at scale to, like, suck air in through a treatment facility and remove particles from it, the way that we're doing with water, right? So it's actually very dissimilar in that way, even though we cover them in the same section here, right? It's really more about regulating, preventing, monitoring, getting a handle on things, making sure that there's proper permitting, right? And just generally stopping it before it gets there, because it can't really be removed. Air pollution is much more of a so-called hyperlocal issue. What does it actually mean? It means that you can have one city block where you've got like a construction site that can have super high, dangerous levels of air pollution, and then you go one street over and it's totally gone, right? So, on our phones, right, we can see the air quality index and get an idea of how, like, bad it is as a floor, like it's at least that bad, but this can vary heavily. So in general, right, if you have the sense that air in a certain place is polluted and your phone tells you it's safe, should go with what you sense on that one. Vehicle emissions controls are a huge part of keeping this under control, especially in Arizona. Vehicle emissions are a huge part of what contributes to municipal air pollution in general. And something that we may or may not know, part of the reason why we might have noticed that our gas prices are higher here in Phoenix than surrounding areas, I remember noticing that gas prices were higher here in Phoenix than up in like Payson or something, is because there are additives in the gasoline that reduce the total amount of emissions and make the air pollution better. I'm not going to weigh in on whether I think this is good or bad policy, because to be honest, I haven't deep dived into the specifics, but it seems like it has been very important and effective, and we'll kind of leave it at that for there. For the next section, we talk about restoration and remediation, and what that process looks like of finding the damage, and finding a way to get things back to a better state. So stick around.